Welcome to Every Animal Has an Owner, a mostly large animal podcast for veterinarians and the people that depend on them.
For epitope homology, it's really about focusing on that protein structure that will be formed based on the genetic code or the gene of interest. And an example of that is, with a coronavirus, and it doesn't matter if you want to talk about COVID or respiratory corona in cattle or porcine epidemic diarrhea virus in pigs, which is also a coronavirus. All coronaviruses are somewhere around 30,000 nucleic acids in length, and so that's their genetic code. But that 30,000 nucleic acids isn't really or nucleotides isn't what the immune system reacts to. It reacts to the proteins that they code for. And in the case of coronaviruses, those 30,000 nucleic acids code for 4 major structural proteins, 16 non-structural proteins, and 8 accessory proteins. And one of those major structural proteins is one that most people have heard of, which is the spike protein. So it doesn't matter if we're talking about COVID or coronaviruses in cattle or PEDV in swine, the spike protein is the most important protein when it comes to having an effective vaccine. And the spike gene happens to only be around 10% of the total virus's genome. And so we start to focus on that gene, the spike gene, for the spike protein. So the receptor binding domain of the spike protein is only about 600 amino acids. So in the end, epitope homology and focusing on the epitope means often, like in the case of coronavirus, you're focused on the 1% of the entire virus genome that matters to the immune system. Antibodies don't recognize the whole virus. They only recognize small pieces of the virus. And so we focus on those small pieces that are referred to as epitopes, because if we can get an antibody response to the epitope of small portion of the total virus, you can neutralize the entire virus. And so for us, it's not just about the gene and the gene of interest and the target gene. It's about what protein does that target gene create. And we make sure that we produce that protein in a way that it looks natural and it's functional for the immune system. And so we get the vaccine to target the specific piece of the virus and the virus's proteins that matter. So you vaccinate the animal, create an antibody response to a very small part of that virus that's key to being able to neutralize it. And at Medgene, that's the technology that we use, and we refer to it as epitope homology.